Welcome for another mathematics lesson. We are going to do three-dimensional geometry. Remember our consultation line is 0704 153 366. So we're going to handle the question here, whereby we are told that the figure below shows a right pyramid standing on a rectangular base ABCD. AB is 8 centimeters, so AB is 8 centimeters. BC 15 centimeters. And each of the slanting edge is 12 centimeters. So these slanting edges are 12 centimeters each. Then we are further told that M is the midpoint of BC. M is the midpoint of BC. So this part here is the midpoint of BC, that is point M. We are told to calculate to 1 decimal place. So 1 decimal place is the accuracy in this question. The vertical height of the pyramid. So to calculate the vertical height of the pyramid, you first of all have to identify the vertical height, which is VO. And VO can only be calculated if we first of all get the diagonal of the base, which is AC. So length AC can be determined using Pythagoras theorem, such that 8 squared plus 15 squared, when we obtain the square root, this is going to give us AC, which is our diagonal there. So 15 squared and 8 squared, then we take the square root, that gives us 17 centimeters. Therefore, AC is 17 centimeters. Now we are going to use AC, its half, so that we may get AO. So the half of 17 is 8.5. Therefore, AO is 8.5 centimeters. So with this half, and we have this vertical height dropping here, then we can again apply Pythagoras theorem and use 12 as an hypotenuse and a base of 8.5 to get this height. Therefore, when we take 12 squared and we subtract 8.5 squared, then we pick the square root, we shall get the vertical height VO, such that 12 squared minus 8.5 squared, and we pick the square root. This gives us 8.47, but we've been told to 1 decimal place. So which means the height is 8.5 centimeters to 1 decimal place. We can continue to get the volume of this pyramid according to part B, and volume is always given by a third of base area. So a third of the base area is rectangular, so 8 by 15 multiplied by the vertical height, which is 8.47 as determined in the question above, such that when we multiply a third times 8 times 15, then we are going to get 338.8 to 1 decimal place cubic centimeters. So that will be the volume of this pyramid. The volume of this pyramid. Again, we are to get the angle between plane VBC and the base. So plane VBC is this one, VBC, and the base. So the base is ABCD. Angles between two planes. Remember, for planes to meet, they must be having a common line now, such that BC is common to both planes. Therefore, a line perpendicular to BC from one of the planes and another one still perpendicular to BC on the other plane are meeting to make a certain angle. Therefore, using this plane, we have a line, and on the other plane, we have a line, and the two lines are making an angle. That is the angle between the two planes. So an angle between two planes is usually an angle made by two lines, each perpendicular to the common line at the intersection of the two planes. Therefore, now we can calculate the size of this angle. Remember, we have the length of OM. OM is going to be, since the whole of AB is 8, then this is going to be 4 centimeters. So OM is 4 centimeters, and we have the height of 8.5, such that because we have this height and the base here, then we want this angle. We don't have the hypotenuse. So the quickest trigonometric ratio will be tangent, such that the tan of that angle is given by the opposite side, which is 8.47 divided by 4, which is the adjacent side, such that now we can obtain theta by taking the tan inverse of 8.47 divided by 4. So we can check which angle is this. So the tan inverse of 8.47 divided by 4 gives us an angle equivalent to 64.72. 64.72, but remember we are calculating to 1 decimal place, so it will just be 0.7 centimeters. 0.7 centimeters. Okay, finally, we have another question here, which tells us to find the angle between VA and the plane ABCD. Therefore, VA is a line and ABCD is a plane. Angles between a line and a plane are usually the angle made by the line itself and its projection on the said plane, such that VA, which is the length here, VA, makes a certain projection on the base OA or AO, such that VA and AO are making a certain angle. That is the angle of interest. The angle of interest. Therefore, the angle of interest can now be calculated. Since we have 8.5 and we have a 12, then we can get the angle made here, such that the vertical height is dropping like that, making it right angled at this point. So we can use the sine. Okay, we want this angle, so I think cosine will be most appropriate. We have 8.5. Therefore, we can say the sine of that angle, cosine of that angle is going to be, the cosine will be given by the adjacent side, which is 8.5, divided by the hypotenuse, which is 12. This means we can get the theta angle by taking the cosine inverse of 8.5 divided by 12. So this will give us cosine inverse of 8.5 divided by 12. And the angle will be 44.90. 44.90 degrees, because it is to 1 decimal place, then 0.9. So that is how the question should be answered. Make sure you subscribe to Shifting Grades and share this link with your friends. Thank you.